Okay, we're going to start Chapter 6, Rational Expressions and Equations. We're going to start with multiplying and simplifying rational expressions. We're going to find all numbers for which a rational expression is not defined. We're going to multiply a rational expression by 1 using an expression such as a over a. We're going to simplify rational expressions by factoring the numerator and the denominator and removing factors of 1. We're going to multiply rational expressions and then simplify. So when we talk about a rational expression, it is any expression that can be written as a quotient of two polynomials or a fraction, okay? Examples of rational expressions are 8 over 11. Now quotient means division, so you could say 8 divided by 11. 6 over x minus 5, the trinomial x squared minus 3x plus 8 being divided by or over 8 x squared minus 9, and then 3y plus 8 plus 1 over y. Rational expressions are examples of algebraic fractions. They are also examples of fractional expressions. Because rational expressions indicate division, we must be careful to avoid denominators that are 0 or that will equal 0. So for example, it says to find all the numbers for which a rational expression x plus 3 over x squared minus 3x minus 28 is undefined. So basically we're going to factor this. So when we factor, we get x minus 7 times x plus 4 equals 0. And then we say x let me get my pencil to work. Okay. Then we say x still had the eraser going. So we're going to say x minus 7 equals 0, x plus 4 equals 0. So x equals 7, and then x equals negative 4. So if we were to plug those in, that would make that bottom number 0 if we were to plug them in. So that's why we want to make sure that we know that we don't use 7, and we would not use a negative 4, because that would make the bottom number or the denominator undefined, and that's what you always want to avoid. So multiplying rational expressions, a over b times c over d is the same thing as ac over bd. So you just multiply the numerators and then you multiply the denominators. This is what we've been doing. Equivalent expressions are expressions that have the same value for all allowable or meaningful replacements are called equivalent expressions. We're going to talk. Okay, when you have 4x plus 3 over x plus 1 times 1, you can let that 1 be anything. If we just chose a number, just arbitrarily, we could have chosen anything. We could have said, I don't know, 3x over 3x. That would simplify to 1, and that would leave us as 4x plus 3 times 3x over x plus 3 times 3x. We just arbitrarily picked 3x. Anything could be 1. We could have said x over x. We could have even said 10 over 10. We just wanted to simplify to 1. So that is an equivalent fraction. So simplifying rational expression. A rational expression is said to be simplified when the numerator and the denominator have no factors other than 1 in common. To simplify a rational expression, we first factor the numerator and the denominator. We then identify factors common to the numerator and the denominator, rewrite the expression as a product of two rational expressions, one of which is equal to 1, and then remove the factor that is equal to 1. It sounds harder than it actually is. Okay, for example, we have 9 times x times x. Now, can we get 36 broken down to where we have something in common? We can. We can go 9 times 4, or 4 times 9 times x. And then look what's in common. You have a 9 and you have an x. So what is left would simply just be the 4 on the bottom and the x on the top. And so that is simplified. Now, when you're dealing with polynomials, the first step would be to factor the numerator or simplify the numerator as best you can. So when we're looking at the x squared plus 2x minus 15, we're going to factor it. And that becomes x minus 3 times x minus 5. Remember, I'm doing your factoring for you. Then we have x minus 3 and then x plus 3. These cancel here and here, so our final is x minus 5 over x plus 3. So it's not as difficult as you think it is when we start working with problems. Okay? So let's look at the next problems. Now, let's look at the top. Is there anything in common that we can take out of the numerator? 8a squared plus 28a. There is. We can. We can take a 4a squared, and that leaves 2a plus 7. And in the bottom, we can actually take out a 4a. Sorry, this one's not a 4a squared, it's just 4a. So then we can take out a 4a, and then we have a plus 3. So the 4a's go away, and we are just simply left with 2a plus 7 over a plus 3, and we are finished. Okay, let's look at the other one. We have x squared plus 2x minus 15. So we're going to factor that. I think we already did this one. So we're going to have x minus 3 times x plus 5 over x minus 3 times x plus 3. I think we just did this one on the previous slide. Anyway, these cancel, so we are left with x plus 5 over x plus 3. And those are our final answers. So basically, all we're doing is canceling things out. And they're looking at the last problem, or the problem that we did twice, and they're canceling. So canceling is a shortcut that can be used and easily misused. To simplify a rational expression, canceling must be done with care and understanding. Canceling streamlines the process of removing a factor equal to 1. So these are things that we have to be very careful about. So for example, let's simplify this one by factoring first. So when we factor, we're going to get y minus 2 times 2y plus 3 over y minus 2 times y plus 4, and then these two cancel here and here, so now we're left with 2y plus 3 over y plus 4, and that's our final answer. Factors that are opposite. Now this is when it gets a little bit different and you have to pay a little bit of attention on what you need to do. You can do it a couple of different ways. First, you have to factor out the GCF over the numerator and the denominator. So when we factor this one, we're going to get x minus 3 over 2 times 3 minus x. Now, what do you notice about the numerator and the denominator? Yes, the x is positive in the numerator, but it is negative in the denominator. So you can do a couple of different things. You can factor out a negative 1. So to do that, we're going to say x minus 3 over 2 times negative 1 times, and you can change the order too, we're going to get x minus 3. So that works. These cancels here and here, but remember, if it's in the top, you're going to have a 1 still left up there, so be very careful of that. So now we have 1, and then 2 times negative 1 is going to give us negative 2. So our final answer is negative 1/2. So just be careful. That's what we meant by being misused. In the canceling, people forget that there's really a 1 there. Alright, this one says multiply and, if possible, simplify. So let's multiply first. So basically we just multiply 5 times 6a to the 4th. So we're going to get 30a to the 4th. Whoops, let's make that 30. And then on the bottom you get 10 times 6a. So you're going to get 60a. And then now can you simplify that? You probably could have simplified before you multiplied if you wanted to. The first thing I notice is that 30 is half of 60. So that gives me 1/2. And then I have an a here, but I have 4 of them here. Remember the rules. Take the smallest to the largest and subtract. So that's going to give us a to the 3rd. So our final answer is a to the 3rd over 2. And you could have factored it out if you wanted to, and that would have made it a lot easier if you needed to done prime factorization. So if you did prime factorization, you would have 2 times 3 times 5 times a times a times a times a over 2 times 2 times 3 times 5 times a. And then just cancel out the things that are the same. Those 5's go away, that a goes away, this 3 goes away. So how many a's did we have left up here? We had 3 of them. And then look what we had on the bottom, simply just that 2. So either method works. You just have to figure out which one works for you. Alright, so let's look at this one. The first thing you have to do is you have to, you've got a trinomial over a binomial, and then you've got 2 monomials. I'm sorry, a trinomial over a binomial, and then you've got 2 binomials being multiplied. I would factor first and see if there's anything that I can cancel. So I'm going to factor the numerator, so I'm going to get x plus 4 times x plus 1. And I'm going to go ahead and multiply it times that x minus 3 over x plus 3, x minus 3 times x plus 4. Now, is there anything in there that you see that we can cancel? I think there's quite a bit that we can cancel. So the x minus 3's can go away, the x plus 4's can go away. Do you see anything else that we can take away? Nope, so we are simply just left with x plus 1 over x plus 3. Okay, on this one, we have x squared plus x minus 20 over 21 times 7, 3x squared minus 11x minus 4. So if it were me, I think I would factor everything first and then go from there before I even multiplied. So let's factor the x squared minus x minus 20, and that factors to x minus 4 times x plus 5 over 21. Let me erase that. Times 7 over, let's factor this, we get 3x plus 1 times x minus 4. Now let's see if there's anything that we can start canceling. Alright, x minus 4 looks like it can cancel. 7 goes into 7 one time, 7 goes into 21 3 times. So now it looks like we're left with x plus 5 over 3 times 3x plus 1. Now don't put it back together, just leave it as it is. And that's the end of chapter 6, section 1.